So Ruby just asked a really good question, and then I gave a really terrible example. So what was your question again, Ruby?
So I asked why you said the amount of water coming out of the faucet was different than the amount of water coming out of the faucet. So the amount of water going in here and out of here is different, he said, but it's the same here. So this has a divergence of 0, and that doesn't.
Right.
And I was like, what? The water's not disappearing. That doesn't make any
Yeah,
sense
that was really
at all.
stupid of me. So it was a terrible example. Let me try giving a different example, because I sort of made a bunch of assumptions and it was just being an idiot. Okay. So I want to give a very similar example, but just a slightly different example. So let's imagine that I've got I'm looking at the Earth from the side on, right, and I've got a spring, right? So this spring is kind of bubbling up water, and then that water is sort of spreading over the surface, right? If I just think about confining myself to this sort of two-dimensional surface, right, I could think about this spring as being a source for water, right? That's actually a point where water is being generated. Okay, now it's not really being generated in 3 dimensions, it's coming from somewhere else. But in this sort of two-dimensional abstraction, I would say, okay, I have this plane, right? And in this plane, I have this area where water is being generated, right? And then the water is spreading out from that area across the rest of the plane, right? If that were the case, if I were just looking in 2 dimensions, I would look at this point and say, aha, here, there is a divergence to that. There is a divergence to the field, right? In other words, there's more water leaving that point than coming into that point in
From
2
area?
dimensions.
In 2 dimensions, yes.
Yeah. If I were to look at it in 3 dimensions, I would say, no, there's not more water coming in than going out, because in 3 dimensions, I can see I've got water coming in this way and going out that way, right? So when I look at it just in a 2-dimensional space, it would make sense for me to say, look, there actually is a divergence of water at that point. Now, probably a better example would be to actually think about, say, having a room, right? And I've got a fire in the middle of the room, right? If I think about heat energy, right? At, say, this point, and let's say the room has reached equilibrium, right? So each point at the room is at whatever its temperature is, right? Maybe it's colder here and it's warmer here by the fire, right? And so I'm losing some energy out of the walls, and I'm burning stuff, so I've got thermal energy that's being created here, right? Here in this area, I would say there's more thermal energy coming into, there's thermal energy actually coming out of this point, right? So there's a source there, so there's a non-zero divergence at that point. On the other hand, at this point, right, there's as much thermal energy coming in as is going out. This point would have 0 divergence. Okay, does that make more sense?
Yes.
Good answer. Although from the way your eyes look, I can tell the answer is no. But thank you for indulging me.